Hello everyone, and welcome back to our channel. Today we have an exciting and groundbreaking topic to discuss. Imagine a power source that not only produces no carbon emissions, but also removes carbon from the atmosphere as it works. This revolutionary technology is based on algae, and researchers are making significant strides in harnessing its potential. Algae offer real potential as a renewable electricity source, research shows. The urgent need to transition from fossil fuels to sustainable energy production is clear. That's why a team of researchers at Concordia University is exploring an innovative power source, algae. This remarkable organism not only produces no carbon emissions, but also absorbs carbon dioxide as it generates electricity. Researchers at the Optical Biomicrosystems Lab have recently published a paper in the journal Energies. They describe their method of extracting energy from the photosynthesis process of algae suspended in a specialized solution and housed in small power cells. When configured correctly, these cells can generate enough energy to power low and ultra-low power devices such as Internet of Things, IoT sensors. The idea of the micro-photosynthetic power cell is to extract electrons produced through the process of photosynthesis, says Kirankumar Kuravinasheti, PhD, a MITAX postdoctoral associate at the University of Calgary. Photosynthesis produces oxygen and electrons. Our model traps the electrons, which allows us to generate electricity. So, more than being a zero-emission technology, it's a negative carbon emission technology. It absorbs carbon dioxide from the atmosphere and gives you a current. Its only byproduct is water. Power generated day and night. The micro-photosynthetic power cell consists of an anode and a cathode chamber, separated by a honeycomb-shaped proton exchange membrane. The researchers fabricated microelectrodes on both sides of the membrane to collect the charges released by the algae during photosynthesis. Each chamber measures only 2 centimeters by 2 centimeters by 4 millimeters. The algae are suspended in a 2 milliliter solution in the anode chamber, while the cathode is filled with potassium ferricyanide, a type of electron acceptor. Once the algae undergo photosynthesis and release electrons, the electrons are collected through the membrane's electrodes and conducted, creating a current. The protons pass through the membrane into the cathode, causing oxidation and resulting in a potassium ferrocyanide reduction. The process also works without direct sunlight, though at a lower intensity. PhD candidate and paper co-author Dilapan Panir-Selvam explains, just like humans, algae are constantly breathing, but they intake carbon dioxide and release oxygen. Due to their photosynthesis machinery, they also release electrons during respiration. The electricity generation is not stopped. The electrons are continuously harvested. Future potential professor Muthukumaran Pakarisamy, the corresponding author and a professor in the Department of Mechanical, Industrial, and Aerospace Engineering, admits that the system currently cannot compete in power generation with technologies like photovoltaic cells. The maximum possible terminal voltage of a single micro-photosynthetic power cell is only 0 V. However, he believes that with further research and development, including artificial intelligence-assisted integration technologies, this technology could become a viable, affordable, and clean power source. Additionally, the manufacturing advantages of this system are significant. Pakarisamy points out, our system does not use any of the hazardous gases or microfibers needed for the silicon fabrication technology that photovoltaic cells rely on. Furthermore, disposing of silicon computer chips is not easy. We use biocompatible polymers, so the whole system is easily decomposable and very cheap to manufacture.